This is problem number 1 from section 3.1. In this problem it says find an equation for the line tangent to y equals 5 minus 2x squared and at negative 3 comma negative 13. So they want us to find the equation for a tangent line. They give us a function y equals 5 minus 2x squared. First thing we need to do is find the slope so we can actually find the tangent line afterwards. So to find the slope, we're going to use the limit as h approaches 0 of f of x plus h minus f of x all over h. And we're going to do that with this function here. So that's going to equal, if I plug in x plus h into the function, I get 5. So limit as h approaches 0 of 5 minus 2 times x plus h squared minus the original function itself, which is 5 minus 2x squared. Make sure that you put this in parentheses because you're subtracting f of x, so it's going to be minus each of the terms. And that's all over h. Now what I'm going to do is I'm going to take x plus h and I'm going to square each of the, or I'm going to square this this binomial. So x plus h times x plus h gives you x squared. This will be xh and xh, so that's plus 2xh, and then plus h squared. So I can replace this x plus h squared with x squared plus 2xh plus h squared. So that equals the limit as h approaches 0 of 5 minus 2 times x squared plus 2xh plus h squared minus 5 plus 2x squared. Now remember, our goal here is we're trying to cancel h out of the denominator because we can't plug in 0. We can't find the limit because we'll be dividing by 0. And this whole thing gives us a slope. Right? This is what's going to give us a slope, essentially. So let's go ahead and distribute this negative 2 to each term, and we end up with the limit as h approaches 0 of 5 minus 2x squared minus 4xh minus 2h squared minus 5 plus 2x squared all over h. I can cancel some stuff. 5 and negative 5 cancel. Negative 2x squared and 2x squared cancel. And I'm left with limit as h approaches 0 of negative 4xh minus 2h squared all over h. I need to factor out h in the top, so that's going to be equal to limit as h approaches 0 of h negative 4x minus 2h all over h. The h's cancel, which was the goal, and so I get limit as h approaches 0 of negative 4x minus 2h. So I can plug in the limit now, and when I plug in h of 0, I get negative 4x minus 2 times 0, which is negative 4x. Now remember, this is the expression for the slope at any point on this line here, or on this quadratic here. So they want us to find the slope at a specific point, which is negative 3, negative 13. So if we want to find the slope at that specific point, we're going to say slope at negative 3, negative 13. We'll plug negative 3 in, so we'll have m equals negative 4 times negative 3. And that tells us that the slope at that spot is 12. So if I want to make the tangent line now, I start with y equals mx plus b. I plug in the slope, which is 12, so I get y equals 12x plus b. And because I need this tangent line to go through this point, I use the point for x and y to find the y-intercept for b. So negative 13 goes in for y, equals 12 times negative 3 plus b. This gives you negative 36 equals negative 13 plus b. Add the 36 over. 36 and negative 13, that should give you 23 equals b. So the tangent line is y equals 12x plus 23. So this line is tangent on this curve at this point.